Hi everyone, today we're going to learn about how to solve systems of equations. And this is when you are given two or more equations and you have to find the intersection points or basically the points that satisfy all of the equations. And there are three ways to solve systems of equations. First one is graphing. In the graphing method, you're just going to graph both all of the equations and then find the intersection point visually or using a graphing calculator or anything you have. And the second method is substitution, and that's when you isolate a variable and either solve for y or x and then substitute that into the other equation to solve for one of the variables. Then the last method is by elimination. And this is when you take two equations and then you add them, and then you try to isolate one of the, or take away one of the variables so that you're only left with one and you can solve for that. So we're going to do some practice problems. And first we'll start with graphing. So we're going to use the graphing method to solve this system. And I graphed this equation, both of the equations here, and this is x plus y equals 1. And this line is 3x minus 2y equals 8. And so we're just going to look for the intersection point visually. And it's right here at 2, negative 1. So basically that's our solution. And the graphing method is good. It's pretty easy. But the only problem with it would be if the intersection point is not easy to see. For example, what if it was here or what if it was here? It'd be kind of hard to find the point without a calculator. So then we can use the algebraic methods, which is either substitution or elimination, to solve the problem. So we're going to move on to substitution. So in substitution, we're going to try to isolate one of the variables, and we could either start with the first one or the second one. But the first one is a bit harder because we have 3x and then 2y, so we'll have to divide it, and we're going to get some fractions and stuff. So we're just going to stick to the second equation. So we can either solve for x or for y, it doesn't really matter. I'm just going to do x. So x equals 1 minus y. And then what I'm going to do is I'm going to substitute this into this equation. So first we have x equals 1 minus y, and then we have 3x minus 2y equals 8. So this one is from this, and the second part is I just copied it off the side. So I'm going to substitute this x value into this. So 1 minus y minus 2y equals 8. So what I've done was I just plug this into this. Okay. Then I'm going to solve for this. So 3 minus 3y minus 2y equals 8. So we have minus 5y equals, and we're going to subtract 3, and we have 5. So we have y equals negative 1. So that's one of our solutions. But we also need to find x. And so to find x, we're going to plug this into this first equation. So we can plug this into one of these equations too. But since we already have x equals here, it's going to be a lot easier to plug it in there. So x equals 1 minus, and y was negative 1, so we get x equals 2. Then we're going to combine these two solutions, and then we get 2, negative 1 as our solution. And we can check it with the graphing. 2, negative 1, so yes, we know this one is right. Okay, now we're going to move on to the elimination method. So in the elimination method, we are going to try to add these two equations and so that we can get rid of one of the variables. So we can either multiply the second equation by negative 3 to isolate the x value or x variable, or we can multiply it by 2. And I'm just going to multiply by 2 because 2 is a smaller number, so it's a bit easier. So I'm just going to multiply that by 2, and I get 2x plus 2y equals 2. And I'm going to bring this equation over. It's the same thing. I'm just going to copy this down. Okay. So then we have this equation, number 1, and we have this number 2 equation. So we're just going to add these, and if we add them, we know that the y's are going to cancel because negative 2y plus 2y is 0. So that's good because it leaves us with just the x variable, so we can actually solve the equation. So we're going to do 1 plus 2, this first equation plus the second equation, and we get 5x, and this is just 0, so plus 0 equals 10. So we get 5x equals 10, then we get x equals 2. So now all we're going to do is we're just going to substitute x equals 2 into one of these equations, either this one, this one, or this one. We can just choose either one. It doesn't really matter. But I'm just going to choose this one because it's easier. So x plus y equals 1, and we're going to substitute x equals 2 into this equation. So we have 2 plus y equals 1, y equals negative 1. So now we have our solution, 2 comma negative 1, and we got the exact same answer for graphing, elimination, and substitution. So all of these methods work, but you have to just choose which method is the easiest when you're trying to solve the system. And so, for example, for this problem, I would probably use the elimination method because both of these equations are in standard form. But if the equation were to be in y equals mx plus b form, then I would probably use substitution because then it's just easier to substitute the y value into the other equation. So we're going to start with some practice problems. So we have this problem first. 4x plus y equals 12 and 2x plus y over 2 equals 4. So first I'm going to take the second equation and multiply by 2 to get rid of the fraction. And this equals 4x plus y equals 8. And so now we have this equation and the first equation. So all we need to do is multiply the top equation, or we can do the bottom, but I'm just going to do the top, by negative 1. We're going to multiply that by negative 1 so that we can add those two together to eliminate one of the variables. So we get negative 4x minus y equals negative 12. So now the two equations we have are number 1 and number 2. And we're going to add these two equations to get rid of a variable so we can solve the equation. And we get negative 4x plus 4x is 0, negative y plus y, but that's also 0, equals negative 12 plus 8 is negative 4. And here our answer doesn't really make sense. 0 equals negative 4. And whenever you get an equation that doesn't make sense, the answer is undefined or no solution. So undefined or no solution. And this is actually because the two equations in the beginning, this equation and this equation, they're actually parallel lines. And parallel lines never intersect. That's why there is no solution. And we can even check to see if they're parallel. So we have the first equation right here. This is the first equation. We get y equals negative 4x plus 12. Oh, sorry. It's supposed to be 12. Then the second equation, we're going to multiply. So we're going to multiply by 2. So 4x plus y equals 4. And we get y equals negative plus 8. So y equals negative 4x plus 8. And even though the 8 and the 12, although they're different numbers, we still have the same negative 4 and negative 4 right here, which shows that they're parallel lines because the slope is the same. So we're going to move on to the next question. Y equals 3x plus 6 and y over 3 minus x equals 2. So since this is already in the mx plus b form and it has y isolated onto one side, we're just going to use the substitution method and substitute that equation into this one. So we get 3x plus 6 over 3 minus x equals 2. Then I'm just going to divide this and we get x plus 2 minus x equals 2. Then here, x minus x is just 0, so we get 2 equals 2. And this is 2 does in fact equal 2, unlike this previous one where 0 equals negative 4, and that's completely wrong. But since 2 equals 2, and whenever you get something like this where the solution makes sense, then the answer is infinite solutions. Infinite solutions. And that's because this first equation and the second equation, they're actually the same line. And if these two are the same line, that means they always intersect and they have infinite points that intersect because all of the points on the line intersect. Okay, so thank you for watching.